So Friday's class, we discovered that this is a rational function meaning that we have a function divided by a function, which means we have actually a denominator that exists. We know that we cannot divide by 0. So how am I going to figure out what this domain is going to be? How do I figure this out? Thoughts? Let's take some notes. We're going to take some notes on our stamp. Set denominator equal to 0 and solve. So we're going to take negative 4x plus 16, set it equal to 0, and then we can solve this together. I'm going to subtract 16 from both sides. This goes back to Algebra 1, so I know we're good just to do this straight up. Let me know when you're ready if your answer matches mine. What are you guys getting? 4? Am I done? Is that my answer? What does this value mean? What do we know about x equals 4? Because that's really the important question. What happens if I put 4 in for x? What happens to that denominator? Right, so is that okay? No. So if we look at that goal that I had set for you at the beginning, all real numbers x not equal to something, for this question, what's that something going to be? 4. So writing our answer is as simple as all real numbers x not equal to 4. And we're done. Yes, I can. Do we agree that we cannot divide by 0? Yes. So we have to figure out what value of x is not okay. On Friday, some people were saying, oh, it just can't be 0. Well, here it could be, right? What's negative 4 times 0? 0 plus 16. So that's okay, right? But there is some number that if x is that number, I'm going to get 0. So the fastest way to figure that out is to force it to be 0. So that's why we set it equal to 0, and then we're going to solve. Whatever we get as our answer, that's what x cannot be. Yes? So? We're going to keep practicing. This doesn't change. Did anybody have thoughts on number 2? I was just putting it up there just to get our brains warmed up and see what we thought. What do we remember from Friday we cannot have underneath the square root? Negatives. So if something can't be negative, how do we say that in math? How do we use math words for that? How do we use inequalities to say that? Very good. Greater than or equal to 0. So this is an even root function. Underneath the radical has to be greater than or equal to 0. Has to be positive. So just like we set this equal to 0 to figure out what we couldn't have, we're going to take what's underneath the radical, 5x minus 10. If this has to be greater than or equal to 0, guess what I'm going to write right here? Not equal to 0, greater than or equal to 0. And we can solve this. So now we're going to bring back our inequality knowledge from 9th grade. How do I solve? Let's make this interesting. Let's make this negative 5x. Yes. Yeah. How am I going to solve this? Add 10 to both sides. Good. So now I have negative 5x is greater than or equal to 10. Sweet. Who's got the next step? Ashley? Very good for keeping track of that negative. Divide by negative 5. Who remembers what happens when we divide by a negative? Sign changes. So my answer is going to be x is what? So see this goal that we had? All real numbers. X less than or equal to negative 2. Yes? Because we divided by a negative. So as soon as we divide by a negative, back in algebra 1, the inequality sign has to flip directions. Correct. If we had that's a great question. So if this had been 5x greater than or equal to 10, and I had just divided by a positive 5, my restriction would be all real numbers, x greater than or equal to 2. We would not have had to change it. Very good. So let's start looking at keep this out because we're going to reference the warm-up in a second, but let's look at the back of your discovery activity. Can you help me just make sure we're all on the same page with what you got for values? When x is negative 4, what'd you get? Negative 13. Let's try it together. So g of negative 4 equals negative 2 times negative 4 squared plus 4 times negative 4 plus 5. We all agree on that? Okay. We have to remember order of operations. I think this is what might be causing some of us to get different answers. Can I do negative 2 times negative 4? Why not? Yes, we have to take care of this exponent first. This has to get squared away first. Up here, Michael. So what is negative 4 all squared? 16. So now I have negative 2 times 16. Let's keep going. What's next? Is it? Minus 16 plus 5. So now I have negative 32 minus 16 plus 5. What's that? Negative 48 plus 5. Okay, I got negative 43. Who got negative 43? Sweet. What about what's g of 0? What'd you get for that? Okay. How about g of 0.25? Can we agree on 5.8? So this came from doing the exact same process, but instead of plugging in a negative 4, g of 0.25. And go through the same exact steps, but with 0.25. Do you want? Who wants to see that? Anybody want to see it? Okay. I don't have space, so let me just add a second page, okay? Is that okay? So help me out. So it's going to be g of 0.25 equals negative 2 times 0.25 squared. What came next? Plus 4 times 0.25 plus 5. So let's do this again. What has to come first? The exponents. We have to square this first. So that literally means leave negative 2 alone. What's 0.25 squared? Say it again. 0.125. What's 4 times 0.25? Those of us who didn't get this, let's get those calculators going. Try it right now. If you need to borrow one of mine, they're back here. 1 plus 5. Okay, let's keep it going. Negative 2 times 0.125. Adisola? Okay, so let's fix that. 0.06. Better? Awesome. Nope, 5. 0.0625. And then negative 2 times 0.0625. Negative 1.125. Plus. Okay, so if I change this to a 0, I'm good. Okay, negative 0.125 plus 1 plus 5 led to what as a final answer? $5.875. Talk to me. 6, good, minus the 0.125 because that's negative out front. So check to make sure that you kept your negative. It could just be as simple as a sign error. It happens all the time. So check your signs. Okay, good conversation. Let's come back to here. Did all of these values work? Yes. In fact, when I come in from the left and I come in from the right, do you see any restrictions? No. So our conjecture for quadratics? No restrictions, all real numbers. So update your homework. This is going to be our official notes by the time we're done. No restrictions, all real numbers. Now this one, we took a look at a little bit in the warm-up, and I just wanted to see how your discovery went over the weekend in terms of figuring out what you can't have. We'll go through this one together. F of negative 1 just means I'm plugging in negative 1 where I see x. So that's going to get me what underneath the radical? Which equals the square root of... Can I do square root of negative 3? No. Did your calculator say like error? So let's write error. And in fact, this represents an x value, right? Look at negative 1. Do you see any graph right there? Nope. Okay, how about f of 0? F of 0 is going to be 0 minus 2 underneath the root, which gets me what underneath the radical? Did that work in your calculators? No. If I look at 0 as an x value, do you see any graph? Nope. Okay, let's try f of 6. I get 6 minus 2, square root of 4. What is the square root of 4? Oh, that worked. And if I look at 5, 6, there I'm okay. So by means of these errors, we can deduce that we cannot take the square root of what kind of number? Did anybody have trouble putting the cube root into the calculator? So make yourself a note. The third root of x is the same as x to the 1/3. The cube root, just notation. There's no math involved in this. This is just purely notation. The cube root of x is the same as x to the 1/3. Guess what the square root of x is the same as? X to the 1/2. Purely notation. No math involved. Don't overthink it. It's just notation. Make a note for yourself. Highlight it. This is going to come back up. So in your did anybody successfully get this into your calculator? What'd you get for, let's just get values on here, people can try later. Anybody else get those? 1? Okay, so just make a little adjustment. The point of this though, when I come, do you see any restrictions on this graph? So this is one all real numbers. So odd roots, third root, odd roots, no restriction. Is 3 an odd number? Yes. So third root, give me another example of an odd root. Ninth root. What else? Fifth root. Any odd number, the graph will always look like this, where I come in from the left, come in from the right, and I hit arrows. Even roots have restrictions. So square root is going to have restriction. What's another even root? Fourth, sixth. Good. Discovery complete. Let's get conclusions all in one place. Can I have volunteers to pass this out? So keep out your warm-up and keep out your discovery, and we're going to get all of our conclusions onto one piece of paper. So I would take out your highlighter and I would highlight the 4. Okay? Highlight given, none, even root, and x in the denominator. This is going to be an awesome graphic organizer by the time we're done. We're going to get all of these awesome ideas that have been floating around between the warm-up and the discovery all into one place. So I'll highlight with you. So given, we have 4 cases. Given is the first, and I'll explain what that means in a moment. Now, what given means, we'll work on that after, because I have to take all those down. See, that's why I need help. What given means is literally, I gave you one, right? If I covered this up, pretend like I hadn't written this, what kind of function is this? Linear. From Friday, do linear functions have a restriction? No, but did I just give you one? Yes. Okay, so the y can have functions that on their own have no restriction, like this one. This is a linear function. On its own, it has no restriction. But like you just said, how did this end up with a restriction? Gave you one. That's it. So the how is, it's given. That's it. It's given. So in this case, here you're given x greater than or equal to 10. You're told that that's the restriction. And let's formalize that with all real numbers, x greater than or equal to 10. So that's all that given means, is that you have a function like this one that typically does not have a restriction, and you are given one. Now, from our discovery, yes, it's given. Right here? Here? Here. Here, given all real numbers x greater than or equal to 10. Yes, Cassidy? Here? That's meant to be a comma. I'm sorry. Comma. Let me make it smaller. Better? Okay. Great. Now, from our discovery, take a close look. There are three functions that do not have a restriction. We actually did just talk about one. So the y, we'll figure out what they are. Three functions that have all real numbers as the domain. Who can give me one? Look at your discovery. There's three that we said have no restrictions. Start on the front. Let's all be on the same page. Look at the front of the discovery. Cassidy? Linear functions. 1. Linear functions. Linear functions, I'll move this over so we can fit a drawing. What do linear functions look like? Lines, straight lines. What's another one? What do those look like? U's either can open up or down. And then there was one more. We only talked about it briefly, but what is it? Cubed root. Or in more general terms, what kind of roots? Odd roots. So that's what we're going to say, odd roots. Odd roots, for example, third root of x. And odd roots, they kind of look like a straight line with a bend in the middle. Like so. Or like so, starting from here, decreasing, or starting, decreasing, and then increasing. Why do none of these have restrictions? Yeah, when I come in from the left, arrow, come in from the right, arrow, and do you see any gaps in the middle? No. So, kind of ran out of room because of my pictures, but we'll make a note. No restricted x values. It's always negative infinity to infinity. So if you see a function that's linear, quadratic, or an odd root, is there any work involved in determining those domains? No. Right away, all you can tell me is all real numbers, and you're done. So let me say that one more time for emphasis. If you are given a function and it is linear, quadratic, or an odd root, is there any work involved? No work. Right away, what do you say for the domain? All real numbers, and you're done. Now, these two we're going to spend some time on, okay? Both of these we looked at in our warm-up, so have your warm-up out. Even roots. So, for example, f of x equals the square root of x. The reason why cannot take a square root or an even root of what kind of number? Of a negative number. That's the reason why. We cannot take the square root of, or even root in general, of a negative number. So let's come up with another example. Let's say m of x equals the square root of negative 2x minus 12. The how. Take what's underneath the root, and by root I mean this symbol, set greater than or equal to 0, and solve. Can't put it any more simple than that. Take what's underneath the root, set greater than or equal to 0, and solve. To make this more interesting, let's add a plus 3 at the end. This will allow us to pay attention to something very important. What's underneath the root here? Do I include that plus 3? No. So one strategy is just highlight what's underneath the root. If it helps you to see it, you can actually highlight this piece. That is where the restriction is. So, what are we going to do? What am I going to write? What do we just say we're going to do? Negative 2x minus 12. Good. Go for it. Let's find the domain. We took what's underneath the radical, set it greater than or equal to 0, and we're solving. How do we match? We don't match? We do? Who matches my answer? Yes. So for any even root, square root, fourth root, sixth root, you take just what's underneath the root, greater than or equal to 0, and solve. Now this one I threw in our negative so we can remember, if you divide by a negative, the inequality sign does need to change directions. Yes. Inequality sign flips. Yes. This plus, great point. This plus 3, nothing to do with our domain. When we get to learning about shifts, you'll see what that plus 3 does. Just what's underneath. So if it helps, highlight. Yes. Cube root is one of our no restrictions, so all real numbers. So that's why if you know, oh, I didn't highlight it. This is very specific to only even roots. So just because you see a radical sign, don't think restriction. No. If it's an even root, yes. Odd root, no restrictions. Good question. What's the invisible number right here? What do you call this? Square is associated with what number? 2. So there's actually an invisible little 2 right there, but in math we don't write it. So if you see no number, it's assumed that that is a square root. Otherwise it's always written. Third, fourth, fifth, it'll always be right there. Okay, uno más. One more. X in the denominator. Why do we have a restriction when x is in the denominator? Because what can we not divide by? So in general, these functions look like you'll see in a book, it'll say this, where you have one function divided by another. Rational function. It's one of our parent functions. It's a rational function because division is involved. So the y can't divide by 0. Cannot divide by 0. Let's do an example, just like we did for our even roots. Here's our example. G of x equals x squared minus 5 divided by 3x plus negative 3x plus 18. So for those of you who like to highlight, what am I going to highlight here? What do I have to pay attention to? Just the denominator. Do I care what's up top? Nope. There could be some ridiculously long function up top. Who cares? Doesn't matter. Only paying attention to the denominator. So the how, like we talked about in our warm-up, take the denominator, set equal to 0, and solve. Your answer will be what has to be excluded. If you're running out of room, just write on the back. Take the denominator, set equal to 0, and solve. Your answer will be what has to be excluded from the domain, because that's what makes it equal to 0. So let's see how this is going to work. What am I going to write for my little equation here? Equal to 0 and solve. Go for it. Equal to 0 and solve. So we're taking the denominator, setting it equal to 0, and now we're solving. What did we get as an answer? Good. Now how are you going to write your domain? Try. What are you going to write for your domain? Tell me. All real numbers. X equals 6? Not equal to 6. Very good. That's what we mean by exclude. Because what happens if x is 6? Let's see. What's negative 3 times 6? Careful. Negative 18 plus 18? 0. So what we're saying is that 6 is the only number x cannot be. Very good. So with this, we should be good to reapproach that worksheet. I had passed it out to you Friday to try. We still have a couple minutes, so let's not be all packing up just yet. It's only 8:12. So make sure physically find this worksheet right now so that we all have eyes on what tonight's homework is. If you see on here what three functions are all real numbers? Linear, quadratic, odd root. So my advice to you, find those ones first. You know the answer for those three right away. Find those first here, and then you'll only be left with the ones that do have a restriction. Okay? This is tonight's homework. Nice job today. If anybody has work to turn in from their grade sheets, I'll take that now. I will also be after school today till 3:30. Well done. Happy Monday, everybody.